once you are capturing sensor data, then I want you to put there a while loop, so sensor data can continue capturing and receiving and collecting, and immediately I want you to post that to our server. So I am talking about today server and communication with between your Raspberry Pi and server that I set in our department server. My primary screen. I think this is my primary screen. If you see the textbook, I'm looking at, for example, page 37, web servers. The lower right corner, it gives you the entire structure of the systems. From your sensor data can be collected by Raspberry Pi, and we're going to learn a simple code, so that code can send out the data to the server, and then server receives the data and save the sensor data on the database. Database that we are using is MySQL. Okay, so MySQL. I'm going to show MySQL also. So once we have done that, then that is the first half of the systems. What that means is that sensor data are collected and posted on the cloud server. There's one end, and the other end is that this sensor data collection is the information pushing systems. So information, sensor data collected and then push it into the server. So server is somehow in between the producer and the consumer. Consumer is for the time being is iPhones, for example. iPhone can be a producer as well, because iPhone itself has very, very strong and meaningful sensors and the features. So if we use those features, then it can also push into the clouding databases. The scenario that we are going to work on this semester is that iPhone is simply the receiver, consumer, okay, and sensor will be the producer. So sensor data can be produced by your Raspberry Pi. Raspberry Pi has both computing power and communication capabilities. Remember that Raspberry Pi has a wireless connections. So through that wireless connections, we need to send the data to the server. Okay, server that we have here. Okay, there's one thing. Before I forget, I need to also explain. This is related to your another homework assignments. Okay, it's kind of it's not really it's kind of a small project. Okay, but what that means is that this is still homework, but the weight portion of this evaluation will be higher than other regular homework assignments. So I wanted to choose a sensor, any type of sensor that can collect, the data can be collected, okay? And then on your program, Raspberry Pi, Python programs, other sample programs are available, right? You can tweak a little bit of those. But don't forget that you need to collect the data using while loop, so continue to collect. The last time that we did is just collection. So within the collection, once it is collected, then you need to send it to the server, cloud server, okay? That part is missing. That part will be discussed today. So I ask you to run that. So data will be posted on the server, cloud server. Okay, that is alphanumerical data. Alphanumerical data will be collected and posted. Number one. Number two, image data. Image data. That is really, really exciting, right? Image data, as I said, the camera is not really right now available for you to pick up. Hopefully, if we hear from our Mercy College department for procurement process, then we may be able to see some. Then I will let you use it. But even though we don't have it, here is my idea. So you don't need to worry about. I think I have my. Okay. This is IR sensor. If you use IR sensor, it's not really contact sensor, surface contact sensor, but remote sensor, remote temperature sensor. A remote temperature sensor can be done by in many different signal, many different waves. One of the powerful wave is infrared signals. If you use infrared signals, that IR, which is an active sensor, right? Most cases, inactive sensor, passive sensors. What that means is that object like animals or mammals or human, our body emits the heats, right? Body heats. So that heat reaches the sensors. So sensor detect that temperature. That's typical, right? Or contact. On the other hand, this IR sensor is that sensor itself emits the signals, then it can reach the objects. Could be animal, mammal, human body, or surroundings, the wall, or something, right? Something environment, ambient environment surface. So two types of sensors can be reflected. So IR sensor usually returns, and then you can capture two types of temperatures, the object temperature and ambient temperature, so surrounding temperatures. Okay, it's very interesting, right? That small sensor gives you that. For example, if you want to use that IR temperature sensors. The one that we tried last week and stopped, remember that we need to download the library. We could download the libraries, but libraries that they developed and the process that we are using, which is Raspberry Pi Model 4. If you are working on Raspberry Pi Model 3, you don't have any problem. But Model 4, there's a problem. So it's not, current library does not work for Model 4. If you are using that particular sensor that we discussed the last moments of the last lecture. So those who are using Raspberry Pi Model 3, 3B, you may try with that. Or otherwise, you may just, pick up some other sensors. But anyway, once you have a sensor, then you need to go to, you need to find out how to, okay, images. So sensor alphanumeric data, sensor data can be posted. That'll be done in a minute once you see the code. The other, imaging. So you guys do not have a camera. By myself, I have one camera, but my own camera may not work for you guys, right? So what I want to do is that what I want you to do, you guys have your cell phone. Anyhow, you have a camera, right? Not camera directly connected to Raspberry Pi, but independent camera, if that is a digital cameras. If we can generate JPEG or, yeah, most likely JPEG, okay? JPEG type of digital images needs to be taken from your Raspberry Pi and the workstation where you have your Raspberry Pi and sensor. That work environment needs to be taken by your, for example, iPhones. Okay, you can take that scenes. The scene should cover most of the features so that we can understand how you are working. Okay, the way that you collect sensor data. So you need to post two different kinds of data. Alphanumerical data, that is sensor data collected by your Raspberry Pi. It may, I want you to take it maybe, it depending upon your sleep time, but maybe 10 to 20 data items sets, okay? If you say, hey, every 1 second, I want to collect the sensor data, then 1 second off, and then 1 second take the data, and on and off, and on and off. So if you take 10 data sets, then maybe you can get them within 20 seconds or something like that, right? Not more than many minutes, okay? So just few minutes or few seconds. That is alphanumeric sensor data. Image data, JPEG data that you can take. You can take that image by your iPhone or any other digital cameras. So I want you to upload where to the same cloud systems. Okay, so I'm still working on that. It's not completely. It's not. There's one thing missing is security issues. So today I am telling you some some program yet it's not secure. But next week that we come back, then I will let you know which is the point of security has been implemented in our entire system. Security is very, very important, right? Sensor data that you collect. I mean, you and I, we trust each other. But who knows? Our server may be open to anyone. Anyone can post. I do not want anybody post if they says, oh, this is alphanumerical data, but it may not be, right? Someone tried to upload some files, but it may not be JPEG file, but some other malicious executable files. All those things needs to be cleaned out, right? Screen it, filter it out. So that type of things, I'm still working on it, in part done, in part will be released next week. Textbook doesn't cover that yet. All right, so here's what I can do. This part is not on your project. You simply use it. But I am explaining to you to understand what's going on somewhere between your Raspberry Pi and all the way up to the cloud server and coming back to your iPhones. Something beyond, okay? That's what I'm going to explain today. My server, our server needs to be accessed by VPN. Okay, so DF Silo VPN. Click this and connect. So VPN is being connected. Okay, so VPN is being connected. Close it. I'll open up the. Okay. If I load this configuration here, what it does, as you can see here, IP. Once we get in the VPN, then this is a private virtual network. So we have our own IPs. That IP address running and known and recognized within this VPN. So outside this VPN, although know that 10.1.0.4, they cannot use this. This is ours. And I'm using SSH connections and open, then I will get the terminal. So I have my own shell. Okay. And it has a server. One of the server is a JSON server. There is a sensor DB. And then we have the program, two programs developed. Upload sensor data. Wait a minute. Upload. Yeah. Here, sensor 2-cell 2db insert.php. This is the program that we are going to use. Okay. So that's MSL. But anyway, this, okay. So I'll show it to you. Sensor 2, cell 2, db insert, the PHP. The server that you need to use is this sitesecure.org JSON slash sensordb slash sensor to cell 2db. This is sensor. Okay. So if I explain about this, this is a PHP file. So in this is PHP, we need to access MySQL database. Okay, MySQL database. So I am going to bring up MySQL also. Let's say like this. So MySQL and minus U for user, sensor to C and minus P, that is a password. That's not true. Oh, wait a minute. Yeah, it's not. Yeah, I should not use that one. So I need to use the terminal inside. So I want to bring up another shell. Sorry for that. So within this, so another shell here. So here MySQL and minus U. And this is MySQL databases. So if I see show databases, then we have that many databases already set up. But I'm going to use the sensor CLSDB and show tables. Right now I have one tables, sensor TV. That table is defined in this way, sensor table. So it has a user ID. So 4 fields, yeah, 5 fields are defined, the user ID, and then sensor type, data type, and then timestamps, and sensor data. Okay, five fields. So if we select, for example, select from sensor TV, then you have so many data already entered. This is the data that I entered the last Wednesday. Yeah, yes, last night, right? Yeah, this kind of data can be posted. Okay, so how can we get the data like this in? That is what happens here is that on your Python, on your, let's suppose that this is your Raspberry Pi, and then you need to run your Python. Excuse me.
Bless you.
Oh, thank you. Oh, you're still there. I was worrying about you guys are not with me.
We're still here.
Yeah, because my systems is too slow. When my system is interrupted, yeah, unknowingly by the college, then it slows. Something that I can not uh, handle. It's not coming. Okay, I think it'll come up. Okay, while this is coming up, let's see. Another thing that you may be able to see. Let me come back here. Let me close this. Let me explain this. So here's what I'm. Rather than view, I'm going to use cat so that you can see it back and forth very clearly. So MySQL is connected. So I have connection. If I do not have a connection, then I can get the data from uh, the HTTP protocols where there is ID, sensor, dtype, timestamps, and some sensor data. Those five data items are posted. Then I receive those five data items. And then what I am trying to do, yeah, here, okay, here. I have an SQL statement, insert into sensor TV. That is a table that we looked at here, right? Into the tables, this is the variables. For example, $UID is the variable. That variable was defined, $UID is taken from that HTTP post protocols, the ID. ID should be clearly, explicitly defined in that HTTP protocols, like sensor, dtype, timestamp, and sensor data. Those are formed here in that insert statement. So insert into sensor DB values, those five values are inserted. So this is at this moment, this is simply a statement, SQL statements. That SQL statements is executed here. Once it is executed, this is execution. Once it is executed, therefore, if it is true, then we can say new record is created successfully. If this is true, unless otherwise, then we can say error, connection errors. Okay. So we can get whatever the data items that the Raspberry Pi sent out will be received that way. What is the Raspberry Pi Python code? Python code actually for example, if it is some data sets are collected, okay, then we need to specify here the particular address, http://scicecure.org. That is what we went in, right? This is scicecure.org. The other ones also. This is scicecure.org. And a particular insert program on that this is the PHP program. And then let's say you collected some data, okay? Then you can say my ID is my name, and sensor, supposedly if there is a DMT11, say DMT11, data type, the temperature, humidity, temperature time is whatever the time that you can get, dt.now, now can be from the time import, and then here, date time as dt. So dt.now is the current time, and then dt.timestamp open and close parentheses, and now then it'll take the current temperatures, current time, and that current time is converted into this timestamps is not the exact timestamp that we look at. For example, 2022 February 24th. This is more like a systemic time, but calendar time can be converted in this way. Time.ctime, and this temp time will be entered here. Then I will have my time. These 5 data sets are formed. Let's say this is my data. No, not yet. Okay, this is the data. So I set it up as a like a dictionary format. ID colon my ID, sensor colon my ID. That is a variable here, my ID. Sense, that is sensor type. D type, that is the data type. And my time, that is my timestamps. My data, that is the sensor data collected here. That is my data. All of them are formed in, this is one record, right? Formed in a dictionary format. We call that dictionary is data. So a request.post, request is a module that we use here, request. That module has a post HTML post protocol. So request.post, this is a function will take URL and data. URL is this is the URL. And then data that I made here as a dictionary, so that is the URL. So we sent that out like this. Okay. So let's assume that this should be collected, but let's assume that manually, if we do that manually, then we can say rather than noon, we can say mercy cyber, and then data type rather than laser 999, we can say LiDAR 1000. And there's the data types, and data may be, I would say 101, 102. Okay. Let's save this. okay, manually if we want to post it manually, but it should be the data that's manually I manipulated, right? This is fake data, but this data should be collected automatically from your sensor. Let's assume that this data collected, okay, particularly uh, this sensor data, my data, okay, yeah, sensor data. This my ID, sensor type, data type, you need to type it. Timestamp should be collected automatically, like this. This is collected automatically. My data, that is, I added it manually here. This is a fake, right? But should be the real data. Let's say that is it. And I want to post it by this request.post URL, same URL over there, and data, that is the data formed in a dictionary formats. So I want to run this. So it goes to that particular URL and then say that is successfully connected. Then we need to see if it is entered here. If it is successfully entered, then it should be appear at the last record. So as you see here, that is at the last records, right? It's very clearly saying that it's a LIDAR 1000, and this is Thursday. This is this current time. Time automatically collected, and this is the data. I said it's fake data, right? 101 and 102. That type of things posted on this database using what? Using this PHP code, okay? Back to the textbook, if you look at where is it? Yeah, page 37, then the left-hand side and on top, that is functioning in this way, because this has been implemented. What you need to do is that, knowing that, hey, there is a PHP files, I mean, the codes are already implemented. Therefore, we simply use it. PHP code appears on your textbook, but we're not going to work on this PHP because this is extra, right? So learning PHP, that is another language. And then if you are a system administrator, then you need to, what you need to do is that you need to set up Apache web server. That's what we did at the server side, and PHP server and MySQL server. In MySQL, you need to develop, you need to create a database and create a table, define a table structure, and get it ready. And also you have to create a user credentials. I'm sure you are not going to use any default database login and database password. You need to create third user ID and password. And then that user ID and password will be used by anyone who wants to log in. Okay, so somehow that is a database security, but web users like end user, like a producer, data producer, does not need to know. Then how can we control the credentials of producers? That should be done, should be screened and filtered within your PHP program. Remember the program that I showed to you? Again, another way that you could do, you can control is for example, there's a similar program, but I changed it a little bit for the security reasons. Let's say I created an array and I put their user credentials and user password. Only those who I trust, so they can only they can come in and upload. Otherwise, anyone can upload and any malicious code on my server, then that'll be a big problem, right? So that credentials can be, in this case, this is hard-coded credentials, but this can be coded in the separate file. So then you need to include that file, and then you need to compare here if any of such user ID appeared in my tables array, which means that person is in the group of a trusted user. Okay. If this gives me true, then I can say, hey, you can come in and post your work. Otherwise, you're not going to do, right? So if it is not the case, then you can say, here, echo, your last name is not permitted. So your username is not permitted. That type of things can be controlled, right? This is already done. So alphanumerical data can be posted on our database. At the same time, images can be also connected. So what you need to do is here, this is a program. That's HTML program. So HTTP scikit.org/JSON, but actually here that I developed. Okay, so this is HTML, so that we can, and once you take photo of your Raspberry Pi and sensor data is running, the idea is this: the sensors, you set up the sensor and Raspberry Pi, so they are running. That is one Raspberry Pi. You can run another Raspberry Pi where you have cameras. So camera is monitoring your sensors. Okay. Any sensor data that posted is about to be, is it vulnerable, or is it kind of a threat, or is it trusted? We do not know, right? So there's two types of the monitoring systems to be installed. So your camera can watch over and monitor. So camera images also posted. So looking at those two, camera images and sensor data. Of course, when you here right now, this is a simple just a simple test program, but but this should be upgraded. I need to ask user login ID and your user login ID, user ID, and something additional. And then I need to check internally IP address. You don't need to put IP address, but this PHP can capture from the packets. So IP address captured from your both sensor data and your image data. So IP should be in the same domain, right? Let's say your image data has nothing to do with your real sensor data, then you cannot put your trust on those two data sets. There's two data, your sensor data and image data, not related. To make them related, then IP address should be somehow related. The user does not need to do that. Systematically, on the server side, there is a server programmer's responsibility. There's my responsibility, right? So I'm going to implement and I will explain it, how they are handle that. So this test program doesn't do that yet. That will be enhanced. This program, what this program can do is that if you take the photo and save it on your computer, or you can do this directly from your cell phones, because this is simply the URL. So from your cell phones, you can take a photo, you can choose the files from your local. Let's say I can choose, for example, these three images. Okay, those three images are the image that there's PNG files that I trust. Okay, and open. Then it says the three files are chosen, and then I upload it. Okay, so somehow it is there. So it is over here, upload, and when you check, then I have some of the upload files. See, I believe these are three files. This is February 24th. Oh, yeah, these three files. 7:36. I think that is current time, right? Those three files are posted. All right. Right now, those three files are posted as a file itself, right? PNG file. So this is a pinout, for example. Go back here. Pinout. Yeah, I think there's this file, right? Yeah, this, or maybe somewhere here. Maybe here. Yeah, I chose this, and three. Swift function sig, maybe that is, yeah, Swift function, yeah, this is the file. Swift function sig, whatever, yeah. Cancel this. So, so internally what this system should do is, once this source image files are saved somewhere here on the server, okay, and at the same time, this name of this file should be saved in a database here. For example, if this is taken by Mercy Cyber, then I would say here the file names. Okay, so I may be able to see this is Mercy server posted that images. So this is a database, right? And then there is another file that you can see here. For example, access.log. This kind of things is also should be maintained in stealthy mode. So user, producer, and consumers do not know. But the server side, the server in stealthy mode to record whatever that we need to know. Okay. So for example, tail access.log, then we may be able to see some of the situations. Here is, for example, IP address. Some of the IP addresses, let's see, remote. Some of the IP address, so 71, whatever that. Those IP, this is not really well organized, but we can make it organized. Who comes through what IP to our server, when, what time. Okay, that type of things needs to be recorded. This is a log files. So a lot of things that you could do for your cybersecurity.